Hey physics students, it's Mr. Thrasher. Good afternoon, maybe good evening, maybe good morning. We are continuing our online learning in this video. This video we are going to look at sound, how we hear sound. But you should not watch this video until after you read an article, one page, easy, about sound. So that's important. Mr. Thrasher is going to show you real quick, if you have not read, where to find this reading. So I'm going to get out of here and let's go to our Canvas page. So here I am in Canvas. I'm in my EL Physics class. This is the first slide that you see, week 3. That's the week we're in right now. Okay, you should have watched a couple videos beforehand. Maybe you did your math practice already. Here's this video. Watch this video on sound waves. But before, you should have read this page. You can open this page. It'll open up. Let's see. Here it is. It's just one page. This is short, little, easy reading about sound waves. So you could print it out, but you don't have to. You could just be on the computer. You could read it on the computer. Now, when you are reading, it says right here, complete this quiz. This is not a real quiz, don't worry. But these are questions about the reading. So you read and answer the question. So you'll see this. Let's see, Mr. Thrasher is going to go like right here. Oh, there's the same paper. It's the same reading. But okay, let's see. There are 5 questions. Here's question 1. It says sound comes from a, geez, I don't know, but it's from the reading. So let's try and read. Okay, at the top, sound waves. Oh, here's a picture. Okay, sound waves move away from the source in every direction. Okay, let's see. Sound waves come from a vibration. That sounds familiar. Look right here. Sound waves come from a blank. Where do they come from? They come from a vibration. So in here you could just type down. What are you going to type? I'll let you type it out. And then go to the next one, true or false. Sound only travels in one direction. Well, let's keep reading and see. Longitudinal sound waves move through the once particle. Sound waves travel in all directions away from the source. This is what you have to do first. You read, and when you are reading, you fill out these questions, just 5. And then you will hit submit quiz, but it's not a real quiz. So do that first, then come back to this video, okay? Then come back. Well, did you finish that reading? So you should know some information about sound. So here is our what do you think? Day number 5. What do you think? Write it down. What was the first sound you heard today? What was the very first sound you heard? One sentence. The first sound I heard today was? What was it? I don't know. Write it down. We are talking about sound. And for sound, we think of 2 things. That's what we're going to learn about. The 2 different ways we can change sound. The first is, in English, the word is often volume. Okay? Mr. Thrasher likes the word loudness. How loud a sound is. So loudness is like very, very loud. This is based on the waves we have already learned about. So here's our notes. How loud or quiet a sound is comes from the sound wave's amplitude. It's the amplitude of the wave. We already learned about amplitude, how tall the wave is. So look right here. This is a little amplitude. So if that was a sound wave, that would be a quiet sound wave. Look right here. The amplitude is bigger. It's taller, more tall. That would be a louder sound wave. So the amplitude is what determines how loud or quiet a sound is. So let's say we're listening to two sounds. Here is sound A. Here is sound B. Which sound is louder? Which sound is louder? What do you think? Sound A is louder because it has a bigger amplitude. A is like this. B is a little bit smaller. Smaller amplitude, not as loud. So A is the most loud. Okay, so that's the volume, the loudness of a sound. There is another aspect of sound, and in English we say pitch, but also in English that's very similar to the word tone, or in Spanish I think the word is tono. The tone of a sound. You sing or you speak with different tones. For example, ready? This is Mr. Thrasher speaking with a high tone. That's a high pitch. Ah. Or Mr. Thrasher could speak with a small or a low tone. So tone and pitch. High tone, low tone, high pitch, low pitch. That comes from the frequency, and we learned about frequency. How fast those waves are moving back and forth, back and forth, back and forth. That's the frequency. Big wave, big frequency. That's a big frequency, fast frequency. That's a high pitch. A slow frequency, that's a low pitch or a low tone. So frequency is what affects the tone. So when people talk, when they're speaking loud or quiet, when they're speaking with high tones or small tones, we're changing the amplitude and the frequency. Okay, Mr. Thrasher has another test. Oh no, my video is covering letter B. I have sound wave A, sound wave B, A and B. Which wave is at a high pitch? Which wave is at a high pitch? What do you think, A or B? It turns out the answer is B, because B has more frequency. It has a bigger frequency, faster. Bigger, faster frequency, higher pitch or tone. So B. Which of these two waves is louder? Which is louder? It's B also. It's B because it has a higher amplitude. Look at this amplitude, 1, 2. This one is 1, and like a half. Okay, this one has smaller amplitude, so louder and higher frequency. Okay, well let's figure out what waves or sound is and what's causing them. You don't have to write this down or anything, just follow along. Sound is created by something vibrating. That's our new word for today, besides pitch and loudness. Vibrating. It moves forwards and backwards. That's what vibrating means, forwards and backwards. Think of something like this. That's vibrating. Think of this person on a jackhammer in English. They are vibrating. Okay, vibrating means to go forwards and backwards very fast. These vibrations, they are pushing on air particles. You take a deep breath, you are breathing in air particles. When you are speaking, or when you have a headphone, a speaker, remember we made speakers? when they're moving, they are pushing on these air particles. And then these air particles, they push on other air particles. This is a little difficult, so don't worry, we'll practice. Air particles start vibrating forward and backward, and they hit other air particles. It's like a collision. They hit, and they make these little air particles start vibrating, like dominoes falling. Oh, sorry, you can't see this. It pushes on air particles all the way to your ear. That's how we hear things. This is difficult. Let me show you some animations. Think of dominoes. Think of dominoes. One of them falls into the next one. One of them goes like this, like this, like this, and like this. The air particles are doing the same thing. They're vibrating a little bit, and they hit the next one, and it hits the next one. It goes air particle, air particle, air particle, air particle, air particle. Let's look right here. Here is our speaker. Here's our speaker that's vibrating back and forth. You're listening to music. The speaker is vibrating back and forth. It pushes on these air particles. Look at this little particle that's red. Look at it. It's vibrating back and forth, back and forth. But then it hits other air particles. So we see our chain reaction. Look at these dominoes, very similar. The wave travels across. So when Mr. Thrasher is speaking in class, you hear me because Mr. Thrasher makes air particles move. And they have this chain reaction, these dominoes, until air particles near your ear are vibrating. So it's coming from these particles going back and forth, back and forth. So it's all about air particles. And it's the same thing whether Mr. Thrasher is speaking or you have a musical instrument that's vibrating or you are listening to headphones or speakers. All these things push on air particles. It travels through the air and then you hear them. It's the same. It's all vibrating air particles. That is how we hear sound. Here's that picture. So something vibrating, maybe a speaker, okay, moving these air particles. Your ear has little bones, and those little bones start vibrating. And that sends a signal. It sends information to your brain. And that's how you pick up sound. Here comes the sound waves into your ear. They make little vibrations, and that sends a signal. It sends information to your brain. That's how you're hearing me right now, from your computer speakers vibrating. Here's another animation. Here comes the sound waves. These are little bones. They vibrate. That sends a signal to your brain. It's all coming from air particles going back and forth, vibrating, vibrating. That's actually the end of my video. That's the physics of how we hear. It's a type of wave. It's a wave that's moving back and forth, but this time it's moving air particles that vibrate, and we hear sound from that. Thanks for watching my video.